Welcome to the topic of integrating trigonometric functions. We will solve cos² theta d theta with all detailed steps. By transforming cos² theta using the identity cos² theta equals frac plus cos² theta 2, we can make integration simpler. Let's explore the principles of calculus and integration together. The identity we will use is cos theta equals frac 1 plus cos² theta. This allows us to simplify our integral. We start by substituting the identity into the integral. Int 0 squared pi 2 theta d theta equals int 0 squared pi over 2 frac 1 plus cos² theta 2 d theta. Let's show it visually. We set up the integral with the substitution. We can split the integral into two parts. Int 0 pi frac 1 and 2 theta plus int 0 pi over 2 frac cos theta d theta. We can now evaluate each integral separately. The first part integrates to frac 1 2 left theta right 0 pi over 2 equals frac 1 2 left frac 2 minus 0 right equals frac 4. Let's visualize this calculation. Now let's evaluate the first part of the integral. The second part involves a substitution. In frac theta 2, theta equals frac 1, 2, left frac theta to right 0 pi 2, which evaluates to 0 because of 0 and sine 0 equals 0. Let's evaluate the second part of the integral now. Combining both results gives us int 0 squared to up 2 that cos 2 theta d theta equals frac pi out 4 plus 4. Thus, the solution to the integral is frac 4. Let's summarize these findings. In summary, we used the trigonometric identity to simplify the integral, split it, and solved each part. Understanding these steps is crucial in mastering integral calculus. Thank you for learning with us. Thank you for your attention. We hope this has helped you grasp integral calculus better.